All right, here's the first of our videos on linear equations, and this one's a review on points in the Cartesian plane. Let's take a look. All right, so when we talk about points in the Cartesian plane, all we're talking about is dots on a graph. So Cartesian plane is just a fancy word for graph. To be able to say accurately where these dots are located on a graph, we need something called a scale on our axes. And the axes are the two lines that you see right here. The left to right one is called the x-axis, and the up and down one is called the y-axis. Now, where the two axes meet is at a point called the origin. This is a value of 0 on the x-axis and a value of 0 on the y-axis. Now, the scale that I was talking about is just the number that we count by on each line. These are like reference points on the grid to tell us how far we have to go in each direction, right, left, or up or down. Now, if there are no numbers written on the axis, we can assume that the scale is 1. If that scale is going to be something other than 1, like if we have to skip count by a certain number, that'll be written right on that grid for us. Now, the position of any point on the Cartesian plane relative to the origin is described using two numbers. One of them's x, and the other one's called y. And this pair of numbers, when used together, is called a set of coordinates. And coordinates are a description of exactly where a point is located in relation to the origin. The x value tells us how far right or left we have to go from the origin, and the y value tells us how far we have to go up or down. Now, that x value is either right or left. And how do I know which direction to go in? Well, if that number in place of x is a positive number, it means I move to the right from the origin. And if that number for x is a negative value, it means I move to the left, just like I would on a number line. And it's similar for y, except that number tells us how far up or down I have to go from the origin to end up at the point that I'm talking about. So if the number in the place of that y value is positive, I'm moving up from the origin, and if the y value is negative, I'm moving down. Now, there's really just one thing you have to watch out for, and that's what scale they're using on the x-axis and the y-axis. And remember, the scale on x does not have to be the same as the scale on y. For example, you could be counting by 2s on the x-axis and by 5, 10s, or hundreds or thousands on the y-axis. One thing to remember here is that once you have a set scale for the x-axis, it has to keep going by that number. So for example, if you're counting by 2s on the x-axis, you can't start counting 2, 4, 6, and then have it change and skip to 10, 12, 18, 25. It's got to remain consistent throughout the entire length of that axis. And obviously the same goes for y. Same goes for y. Same goes for y. Now, the last thing you might need to know about x and y variables is that sometimes, especially in word problems, we refer to them as independent and dependent variables. And for now, the only thing you're going to need to know is that x always represents the independent variable and y represents the dependent variable. And we're going to explain to you what the difference is in a future video. And for now, for this review, let's see a couple of examples of how we locate points on a Cartesian plane.
Okay, we're looking at identifying points in the Cartesian plane. This is question number 1, and the question is pretty straightforward. Identify the coordinates of the points on the Cartesian grid below. And you'll just notice a quick format issue. I've got my answers over here on the right while yours are down below. So first things first, coordinates are sometimes called points. The two words are kind of interchangeable, so don't get confused by that word coordinate. And just a quick reminder that when we're looking at coordinates, that the first value is always an x, and the second value is always the y. And that's just because mathematicians needed to have an order so they could all agree and know how to read one another's coordinates speaking the same language. So we know right away that the first value is always going to be x and the second value is always going to be y. And you can see the x-axis here running left to right or right to left from the origin, and you can see the y-axis here running up and down, or north and south if you like, from the origin. And so every point is really just a set of directions where the first number will tell us whether we're moving left or right, and the second number will tell us whether we are moving up or down. And we'll know whether we're going left or right or up or down based on whether or not x is positive or negative, and based on whether or not y is positive or negative. So the basic directions for points, if you come over here, remembering for the x value that if you're moving left, you've got a negative value, and if you're moving to the right of that origin, you've got a positive value. Whereas with the y-axis, if you're going up, you've got a positive value, and if you're going down, you've got a negative value. So basically, we're going to come over here and find point A. So that's the first one that we want. And here it is. And here's the origin. Remember, this is the key, because we're always going to ask ourselves, how far left or right do we go? Left or right, and how far up or down do we go? And you should see right away that I'm going to the right to get to A. I'm going to have to go right, and then I'm going to have to go up. So I'm going to have a positive x and a positive y in all these points over here, actually. So positive x, positive y, and now all I have to do is count. Since I'm going up by ones, 1, 2, 3, 4, 5, you can see that 5 marker there, 6, 7, 8. So I'm to the right 8, so that's positive 8 for the x. And then from that x-axis, I have to go up to get to my appropriate y. 1, 2, 3, 4 places up. Positive 4 for the y. So the location of this point is 8, 4, or coordinate 8, 4. B is over here. Now for the b, what you're going to see is to get to that b for the x value, I had to go left. I have to go left a certain number of spaces. Let's count. 1, 2, 3. I had to go 3 to the left to get right underneath that b. And then I'm going to go up 9 spaces, I believe. Let's just count it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So backwards 3 or left 3 is a negative 3, and then a positive 9 for the y because I went up from the x-axis, or from the origin, if you will. So for the C now, same thing, starting at the origin, I got to go left, so I'm going to have a negative here right away. I'm going left 9 spaces, backwards 9, and then down 2 spaces, negative 2. And now for point D, starting from the origin, I'm going right. We always do the x first, so right 3, so that's positive 3, and then down 1, 2, 3, 4, negative 4. And that's it. That's how you name coordinates, making sure x's are first, y's are second, and x's are negative if they go left, positive if they go right, and for the y's, negative if they go down, positive if they go up. Hey, we're identifying points in the Cartesian plane. This is number 2, and the interesting with this question is they mention these words independent and dependent variables. So I want you to remember that the independent variable is the one that we're always going to label as x, and the dependent variable is the one that we're always going to label as y. That's, again, a convention that mathematicians use in order to be able to talk to each other so they agree on which one is which. The independent is always the x, and the dependent is always the y. And what makes a variable dependent or independent? Well, it's easier if we think about the dependent for a second. So the y is the dependent, whereas the x is the independent. And the dependent is called dependent because it depends on x. In other words, the value of the y will always depend on what the x is. So as I change x, I affect the y. The value of the y is the one that depends. So if we take a look at the example over here where we have Amanda who's working, and she has a job working for the city, and she makes $40 after working for 2 hours, and after 6 hours she makes $100. So I want you to be thinking about these two concepts here. We've got this issue of hours, the number of hours that she works, which seems to be changing. That's one of the variables. And then she's got how much money she makes, which also seems to be changing in the two instances, right? So at one point she's making $40, sometimes she's making $100, sometimes she's working 2 hours, sometimes she's working 6 hours. This is a really good example for explaining the concept of independent and dependent, because a lot of you know, especially if you already have a part-time job or a friend who has one or you're looking for one, that the amount of money you make depends on how many hours you work. And so since this is the one that depends on that one right there, this is my y. The dependent, the amount of money that Amanda makes, depends on how many hours she works. And so as I change my work hours from week to week, or as my boss does, I will change the value of the money that I've made. So dependent is the key concept here. So if I come back and look at the information, I've got Amanda gets a job working for the city, and she makes $40 after she works for 2 hours. So these two numbers are grouped together. $40 being made after working for 2 hours. So now you need to think about, okay, well, which one's which? Well, we knew that the X is the hour. So she worked 2 hours. In those 2 hours, she made $40. Notice that I don't have to put them in the same order in the sentence, because over here it says after 6 hours she makes 100. So here I started with the money and I went to time. Down here I came to time and went over to money. It doesn't change anything, it's just the way the sentence is written. The big thing to know is which one depends on which. And just like the last time, that $100 that she made depended on the number of hours that she worked. Okay, over here, there was my X, and that was my Y. So 6 hours makes me $100. So those are the ordered pairs. The question says, given the following word problem, identify the independent and dependent variables, and then place the coordinates on the appropriate axis, and then sketch the line that represents the situation. So the next step then is to say, okay, well, after 2 hours, I made $40. Where does that happen? On the Cartesian plane. And then we'll take a look at connecting them up and making a line. So you can see that I'm going up by ones here, and I'm going up by a different number here. To get to that 50, I had to go 1, 2, 3, 4, 5 spaces. And so those 5 spaces, if I go 50 divided by the 5 spaces, I get tens. So that means I went up by tens here. 10, 20, 30, 40, etc. And here I went up by ones. And remember, on the Cartesian plane, that's okay. You can go up by different amounts. It's just that once you pick what you're going up by on the X, it has to stay that way. And once you pick what you're going up by on the Y, it has to stay that way. So 2 hours, $40 earned. 2 hours is your X. $40 earned is right there. And there's my first point, which is 240. I can label that. And the second point, 6,100. Well, here's where the X is 6, and here's where the Y is 100. And so if you kind of think about where that 6 is going to meet that 100, that's going to be right there. And I'll label that one. 6 for the X, 100 for the Y. And then the problem says, hey, take a second and sketch the line. So I can do that. And it's very important that when you're doing this, that you line it up as neatly as you can. And go ahead and make that line. Last thing I'll say is what's really neat about this line is now you can even kind of pick a number that we don't know for sure and find something. So for example, if you take a look, after 4 hours, let me use a different color here just to demonstrate this. After 4 hours, which, we don't know anything about what happens when the X is 4, but check it out. The line will tell us. If I find where the X is 4, and then I come all the way up until I touch that line right there, I can then come all the way over here and see that the Y would have to be 70. And so that's one of the beauties of lines, is that they can actually help us answer questions about information that we know nothing about once we have the pattern set down.